we're going to demonstrate the speech recognition, speaker recognition, and face recognition of RecoMadeEasy by Recognition Technologies. So the first thing we're going to do is take a look at what memory usage there is right now. So about 1.5 gigabytes on this machine are being used. We're going to then start our server, which is going to start the speech and speaker recognition services. And if I check the status now, you'll see that we have one stream basically listening for audio coming in. And the amount of memory has gone up to 2.24 gigabytes. So that's the utilization, and it's basically almost constant. And this also shows how much processing is being used. Now the processing is because of a bunch of other things right now running on the system. So it's GNOME shell doing it, and most of the processing is actually through the recording that I'm doing for the demo. Because right now nothing else is running, although the speech has loaded into the memory. Next, I'm going to show a simple transcription. I'm going to run a client which is going to capture the audio from the microphone, send it through to the listener, and it's going to show the transcript of what I will say. So the way we'll do this is I'm going to do it through the local host because everything's running on the same machine. I'm going to do a quick 10-second transcription. So this is a transcription. My name is Homayun Begi, and I'm basically using the speech recognition system to dictate. So I can also use the diarization, full diarization, which basically uses speech recognition as well as speaker recognition. So not only will it transcribe everything that I say, but it'll also say who the speaker is. So let's do a little bit of a longer session now. So I'm just speaking and it's going to be transcribing what I say. I'm going to pause a little bit so that it creates a new sentence. And as you can see, it also shows that the speaker is Begi, which is who I am actually. So it's identifying me, and it's also doing the transcription. Okay, so here are the results of the transcript. As you can see, there are timestamps, the beginning and end of a segment. So this is for the speech recognition. It's for 5 seconds of audio. And these things that have segment numbers are the outputs of the speaker recognition. So everything is basically Begi with the exception of this little segment. And if you actually look at this segment, you'll see that it's only 0.58 seconds. So that may have been, that is the pause. Remember I said that I'm going to pause a little bit. So I didn't know who that was because that was actually a pause. And it does a transcription. Alright, in order to give you a better idea of how the transcription works and how well it operates, I just turned it on and I'm just going to talk. It's going to be transcribing whatever I say. I can just pick up something from my desk and start reading. There is this card member agreement that I've received, and it goes like this. Details of important changes to your card member agreement. We have the right to amend. It's done anyway, the 30 seconds that I had done. So there you go, that's the transcription. Now I'm just going to do a segmentation only so that you can see how that works. I'm just going to do a short one. We've done this in the context of the diarization, which was doing the segmentation and ID together with the transcript. Now I'm just going to do 10 seconds and it should just identify who I am. So I'm going to talk and it should come back and show the ID of the person speaking, which is, should be myself. And sometimes there are pauses, so for the pause it came back as unknown. There you go. So it has broken things up into little segments. This small segment is unknown, which is where I paused, and then the rest is my name. So there you have it. That's the speaker diarization, which is transcription, segmentation and ID, and then we saw the transcription separately, followed by the segmentation and ID separately. Okay, now I'm going to demonstrate that our speaker ID can be used for other than human voices, for example, for bird calls. So in order to do that, what I've done is I've enrolled 26 birds with a species and subspecies being noted as claimed IDs, and enrolled from anywhere from 10 seconds to a minute of audio from the bird calls, and then taken a few of these birds, but not the same birds, actually the same species and subspecies, and the recordings are from different birds, different location, different microphone, and we're trying to find out if our system can identify those calls. So let's try this. I'm going to run against our birds database, which is the 26 birds that I've recorded, that I've enrolled into the system, and I'm going to give it a media file, which is, let's say we're going to test the audio of this bird, for example, which is called Abelia abelii. So if I run this, you'll see that it basically segments the audio into pieces and then comes back with the top contenders for the different segments. And in most cases, as you can see, it is Abelia abelii. I mean, there are little cases where it thinks it's something else, and you will see that those segments are actually very small segments. Like this is only 0.2 seconds. Then I can do it for, let's say, another bird. Let's see what we have here. We have this guy. Let's see what we get, which is correct for every segment. This is the name of the bird that we were trying to identify, and for all 4 segments it got this. We're gonna try yet another one. Let's try this guy. And to see which the bird was, it was this one, Aethopiga Christianae, which, as you can see, most of the segments actually came back correctly. So if you actually average over all the segments, you'll see that this is the bird call of this one. Let's try another one yet. Let's try this one. Again, this is the bird we tried, and this is the bird we got. I'm going to try another one, which is just to cover all the examples that I have here. This one. Okay, so 2 out of 3 segments came back with the correct ID, and the one that didn't is very small. So this segment is like 6.3 seconds. This is 10.9 seconds. It's only 0.2 seconds. That was another given a result, and this is because it's probably like there's no audio, or there's noise, and it's matching some other profile. But then again, from the average, you can actually tell which bird call it was. So this is just to show you that we can be text independent, language independent, and in fact species independent in this case. That's really our speaker recognition. can be used for many different things, including recognizing different machinery, types of machinery, musical instruments, anything that has a unique type of sort of audio characteristics, not necessarily vocal characteristics. Now I'm going to demonstrate our face recognition engine. So basically, we have the same API for our speech recognition, speaker recognition, and face recognition. But I'm just going to show you the face recognition at this point. So in order to do that, I have all these sort of pieces of media. I have 1, 2, 3, 4, 5, 6 people registered in or enrolled into the face recognition system, and in fact I'm not even sure if they're enrolled or not. So let's do this. Let's actually enroll these people in here. Let me just make sure that I have an account called face. No, and I don't. So you can see how I actually create the account. I can create a new user account very quickly by passing some default configuration, and I'm going to say this is on localhost, and sampling rate 16K 16-bit samples, and then user ID is going to be face test, and we're just going to make the password face test also. That's it. It's created an account. So now if I actually look at accounts, I have something called face test. Now what I'm going to do is I'm going to enroll let me turn off this bell, which is very annoying. Okay, and then we're going to enroll. Let's see what we need to pass. We're going to pass, for example, the user ID, which is face test. We're going to pass basically all our different enrollments. So let's see what we have. Let's pass my video, and because my video is rotated by 270 degrees, I have to tell it that it's 3 multiples of 90 degrees rotation, and I'm going to give it an ID. Actually, that's the way I would pass it. There you go. So it's now enrolling me. It's enrolled me. I'm successfully enrolled into the system. There are 40 frames that it picked from me. I can then try the next person, which is Fallon. Again, her recording is rotated, so I will do this and give her name. She's enrolled. So let me actually play back, like for example, Fallon's enrollment, or even my enrollment, so that you can see what I mean by being rotated. So this is the way it looks. See? I'm just going to close this now. So because of that, I had to give it the rotation. I can now continue and enroll somebody else, which is, this is some from the Mobile database. Female. There is no rotation involved in this one, and I'm just going to pass this ID. Enrolled. Okay. Now we're going to do another one. Yet another person. This is a male this time. I think I have one more person on the in here that I can enroll. Yeah, Richard. So Richard is also recorded with 270 degrees rotation. So there we go, and we'll give a claimed ID. Richard is also enrolled. Now we have everybody enrolled in the system, what we're going to do is now we're going to try the ID. So we're going to pass, let's see what it expects from us. So we're going to pass the user ID, which is face test, which we just enrolled these people in. We're going to give some test ID. So let's say ID, if I pass, for example, a JPEG of myself out of one of my sessions, which is a different session, of course, than the enrollment, and with the rotation. Now there's no rotation for this because it's actually upright. It's going to try to identify this person. So there you go. So I'm the top match, 83%, and the next person is Richard, and then it has a whole bunch of unknown matches, which are sort of unknown models, and so on and so forth. I can do the same thing for example, for this thing, and pass the whole video. The video is rotated, so I have to rotate it back by 270 degrees, and let's see what happens. I need to give it the rotation separately like this. Okay, there you go. So now it's gone through the whole video, and it's taken 11 frames out of the video, and it shows that, again, with 87% accuracy, confidence or score, this is my video. So now I'm gonna try somebody else's thing. So let's try Fallon. Let's try one of her JPEG images, and there you go. Fallon is the top match. Let's try a video, let's say .2 with the rotation. Okay, Fallon again, 90.9%. Let's try Richard. Let's try one of his videos, 3. And Richard is the top match. And let's try one of the Mobio ones. So we have like Mobio F401. No rotation. Okay, there you go, 84%. Let's try another Mobio one. We passed 409, so there you go. We have 409 as the top match. So this is basically our speaker ID. I'm sorry, the face ID, and it can be fused with our speaker ID and with our speech recognition, and you can actually see that if you go to the videos that are demonstrated on our website. That is it for the face recognition. Okay, now that we're done, I'm going to stop the server by just running this, and if I check the status, I'll see that the server is not running, and I'm back to the 1.72 gigs that I was using in memory. And so I use about 600. So we used actually about 600 megs of memory to be able to process all this stuff. And as you can see, of course, the recording is very intensive, and it's using a lot of CPU power. And with all this CPU power being utilized, we were able to still do all the demos much faster than real time. Thank you for listening.